introduced the idea, it's a cool idea, this idea that if you can't find the limit of a quotient function, you can take the derivative of the top and the derivative of the bottom and then find the limit of that. And if you still can't find it, then you can take the derivative again and again and again until you get to some point where the denominator is not zero, but when you plug stuff in, you get some kind of value out of it. Now, there are some rules about using L'Hopital's rule. You have to have that word, indeterminate. You have to have indeterminate form to be able to use L'Hopital's rule. But that's what we did. Let's see. I'm thinking, I don't remember where we stopped on my little example thing. Did we did e to the x minus 7 over 8x squared plus 12x plus 5, right?
We had to do it twice.
Pardon?
We had to do it twice. L'Hopital's.
Yeah, we did that one, right? Yeah. Was that the last one we did? Okay. Now, is that just one nasty, awful, ugly mess?
Pretty nasty.
First thing you do is you plug it in. I can plug this in. Let's see, natural log of 0 over the natural log of 0 minus 0 plus 1. What's the natural log of 0? What does natural log look like? Yeah.
Well, dominator, it's undefined. That's undefined, yeah. Whoops.
But, so we're approaching, as x approaches 0. Yeah, the natural log. So what is the natural log of 0 if we're looking at limits? Right? The output value, you just get closer and closer to this asymptote of 0, and you get farther and farther negative. Well, that looks to me pretty much like negative infinity over negative infinity. Is that indeterminate? Yeah. If you think infinity over infinity is indeterminate, can't negative infinity over negative infinity be indeterminate? I would hope. I don't know. Don't ask me, it's Friday. I've already got weekend brain. So we can use L'Hopital's rule. So let's see what we get. We'll say the limit as x approaches 0 from the positive side of the natural log of x over the natural log of x minus x plus 1 equals the limit as x approaches 0 of 1 over x over 1 over x minus 1. Is that good?
Still determined.
Is it still indeterminate? 1 over 0 over 1 over 0 minus 1. This is it? As x approaches 0 from the positive side? I don't know. Let's try it again. Because maybe next time it won't be so horrible. Oh. Let's just do some magic algebra. Or, let's take the derivative again. Will the derivative help? I don't know. Let's see. What's the derivative of that?
Square? Oh, negative. Same thing.
And of course, the derivative of that is 0. So what have we got now?
Indeterminate.
What? Look at this. We've got negative 1 over x squared over negative 1 over x squared. What's that number?
Oh, one, Oh, it's testing.
Ah, okay. So there we go. We found it. We actually could have found it here using just cleaning this up algebraically, but then this is really cool. This goes to 1. Woohoo! Gosh, somebody needs to improve my handwriting. So, what am I going to do here? Well, whatever I do, I'm going to try to plug in pi over 2 first and see what we get. The sine of, the cosine of pi over 2 over the cosine of pi over 2. Let's see, that's sine of cosine of pi over 2 is 0. Right? What's the sine of 0?
0.
Is that indeterminate? Woohoo! Yes, that's indeterminate. So, L'Hopital's rule. Sine of cosine. Wow.
Chain rule? Oh, cosine of
Yeah,
negative sine.
basically, we're gonna say cosine x is u,
It's cosine of negative sine.
and so then we'll say, well, the derivative of that is negative sine of x. And so we've got the parent being sine of u. And so the derivative, wait a minute, what did I do wrong here? That's what I did wrong. That's my f. Now my f prime is
Cosine.
cosine u. So now I'll put it all back together.
Yeah.
My brain's gone.
On top would just be cosine of negative sine.
Here's what I have in my notes. Is that right? Because I'm confused. I don't know if I plugged it in correctly. Negative sine times cosine of. I did something wrong. What did I do wrong?
You're doing the product rule and it's the chain.
What?
It's chain rule.
It's chain rule, you do the product.
It's the chain rule, I'm fine.
You're doing the product
Because-
You're
rule.
doing the product rule.
Yeah, because chain is derivative of the outside, which is cosine, times the derivative of the inside, which is negative sine.
Yeah, it should be negative sine times cosine.
Yeah. You can just take away that parentheses on the last part you have there, and then you just put an X, it's cosine X.
Are you sure?
Mhm.
Yeah, sure.
Negative sine, cosine.
Sine of this, no. Sine of this, oh, God. My brain is gone.
Just trust us, it's there.
That's it? I'm just supposed to trust you?
Yes.
Are you sure?
That's right there.
I think you had it right the first time, but because it'd be do the cosine first, it'd be the derivative of sine u, cosine u would be cosine x, and then you do the derivative of u, would be the negative sine x. So it'd be cosine of cosine x times negative sine x.
I think he's right.
Yeah, that's what I got.
Don't worry, leave the inside alone.
Oh.
Leave the inside alone.
I'm sorry, my brain's not functioning very well today. It's not very helpful.
No, it's gonna have to leave the inside alone.
Oh, yeah.
Yeah, sorry,
Okay, you can no longer trust your order, that's fine,
you said it.
I did.
You know what? If he were perfect, would he be in this class? Would he even be on Earth? Or would he be floating in the cloud? Okay, what happens when you put pi over 2 into there? You get a value.
Cosine of 1.
Cosine of pi over 2 is 0. Cosine of 0 is 1.
Oh, yeah.
There, we did it. Even Fraser did it. Good heavens, this is not erasing. Get back into it, woman.